Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile Nigeria Physics Clinic. Today we are handling simple alternating current circuits. First, I would like us to define AC current. This is a current in which the flow is impulses or periodic with time. It is not continuous as in direct current. Now mathematically we can say that the current in AC is divided into instantaneous, peak. We also talk about root mean square current, but instantaneous current, listen very well, instantaneous current I is given as I naught sine omega t, where I is the instantaneous current, that's this, while I naught is the peak current. Then omega t is called the phase difference, while V, which is instantaneous voltage, is given as V naught sine omega t. This is also phase difference. V naught is the peak current, while V is the instantaneous current. Now we can separate it into circuits. We have the resistive circuits RC, where these two are correct. Then we have the capacitive circuits, where we can rewrite this as I equal to I naught sine omega t plus pi over 2, and V equal to V naught sine omega t. Note, current can change because capacitive circuit, a capacitor has already stored charge even before we start using it to run moving charges, while the voltage cannot change because at that point EMF cannot come in unless there is a movement of charge. Then we come to inductive circuit. In inductive circuit, voltage will remain the same, V naught sine omega t, while current, instantaneous current, will be I naught sine omega t minus pi over 2. Then from there we can now talk about resistance and reactance. In terms of reactance, there are two reactants we must consider. Inductive reactance, which is given as omega L, which is 2 pi FL. Then we have capacitive reactance, which is given as 1 over omega C, which is 1 over 2 pi FC. And note, resonance can only occur if XL is equal to XC. I quote, resonance can only occur if XL is equal to XC. Bringing it further, in capacitive, we now move further to discuss the impedance. Impedance, which is the combination of the square root of resistance and reactance. Depending on the reactance we have, if we have an inductive circuit, we have Z equal to square root of R square plus XL square for inductive. If it's capacity, we have R square plus XC square. But if it is a complete circuit of resistive, inductive, and capacitive circuit, we have it that Z is equal to square root of X L minus X C all squared plus R squared. This is a complete impedance, and V is equal to I impedance. That means that I is equal to V all over impedance. Now from there we can talk about average power in a system, where we'll have power to be equal to IV cos theta. Cos theta here is called the cofactor or the power factor. This is the power in the system, IV cos theta, which we can also IV, since you know that V is equal to IR based on Ohm's law, so we have it that P is equal to I squared R cos theta, or P equal to V squared all over R cos theta. All these are equations of power. Now before we go into the next topic, models of atom and nuclear physics, that is the modern part of physics on the growing range, most especially now in this country, Nigeria. Radiation has been the study of everybody, even those in PhD program. So my dear, I would really like you to join me in this program and make sure you enjoy it when it runs. But before then, go back and take a detailed study of AC circuits. See you in the next class.